Okay, my friends, Roger, Mud Fossil University, and guess what? They are talking about our research. I don't care what they say. This is our
But the reason
research.
why this is so interesting and thrilling is that, besides being unexpected, this could genuinely be the first sight of something new. Because if, when we've analysed more data, this difference between muons and electrons
I'm going to show you the muons and electrons. We separated them, and then they reattach, and they are almost certainly not going to be equal to when they started.
stays and lepton universality seems to be violated, well, what that means is that there's something wrong with the standard model. We found the crack, finally, in our understanding of particle physics. There's absolutely no way that we can explain this observation with our current understanding. In fact, the only way we think we can explain what's going on is if there are new particles in the universe associated with new physics processes beyond those that we understand, and that these new particles are interfering with the B mesons as they decay and suppressing the decay to muons compared to electrons. Now, if that turns out to be the case, that will truly be momentous. Forget the Higgs. This will be the first sign of physics beyond the standard model. And
Well, let me just finish her up.
it's what we've built the LHC to find out.
All right, here's my contention is that all that exists is electrons. So they're looking for new particles. They should just go and look at the particles that exist and say, what is the smallest particle that exists? Well, what does Roger say? Well, Roger says that's the smallest particles that do exist, and they're electrons when they're together, and when they're apart, they are individual muons, an individual explosive part of the electron. And they can separate and they can reattach. Normally they're attached. When they separate, it's because of explosiveness. And now they realize they don't equal each other, so that destroys everything in the current model. And I have everything that supports my electron flood theory. So here it comes. Okay, shown this so many times I'm going to rocket ship through it. Pulsed red laser, accelerating particle being shown, concussion, white particles separate from the little black particles, electron showers coming at us. This is a new particle nobody knows about. These particles down here are the photons just prior to the concussion at the venturi up here. And at the venturi is where they separate the black ball from the white ball. Now, what does this mean in my theory? Well, what does this mean in my theory? Well, this is what it does mean in my theory, which is electron flood theory, which says that there is nothing more than electrons. And an electron has two components. It has the negative, extremely explosive component, which we always considered only what the electron was. But it is attached to a dark particle, which I showed you is that dark particle attached to the white particle. You'll probably see it again in this presentation, but you've seen it a zillion times if you've been around. The electron has 1,837 of them in a proton. And these would be 1,837 of these little particles in a proton. And that allows you to have isotopes one way this way, so you have 1839 or 1832 or 1836 or whatever. And then when you get a neutral particle, it means you have an even number. Now, photons, as I showed you, the back-to-back little particles, was a photon. That is the smallest particle that most people consider. Electron is half of a photon. Photons are together and they become basically neutral. When they bang into you, they bounce off. When these bang into you, they try to incorporate and burn you. When they smash into something extremely oppositional, you end up with electron showers. And this is not something I'm making up. They know this. They call these electron showers. I agree. They call the black balls neutrino muons or bosons. I agree with that. That's the black ball. But I call it dark matter as well. That's what they're missing. It is dark matter, and it is attached to the electrons. They separate completely one from another in that venturi, 100% separated. And I show this as well in extreme detail right here. This is the venturi, and there is the separation, no question whatsoever. And then back down here, they come back in. It happens to be gravity. It's gravity, it's dark matter, no emission, no absorption, no concussion, no interaction other than come back to me, baby. And that's it, gravity, dark matter. The thing that they've been missing all along, and the Royal Institution admits is a problem. And the only way to solve it is electron flood. Okay, my wonderful friends and my experimenter friends, my extremely interested in reality friends, what are we looking at here? Well, we're looking at the laser experiment, and all you need to do the laser experiment is right here. It's just absolutely unbelievable how inexpensive this is. Before I get started, I want you to understand, these are lasers. What I'm showing you here, these are lasers. Lasers will hurt your eyes. Be very, very careful. Do never, ever look into a laser. Now, they make glasses like that's red ones, and this is blue ones, and I got to be honest with you. I lost interest in doing the experiments myself. Rod Warren did. This is all Rod Warren's original experiments using a venturi, but he was just experimenting. He wasn't out looking for physics. I am. And when I saw it, I went crazy. Now, here's what a photon is. That's light. Okay, that's a little symbol that says photon. And I've shown this a bazillion times, so you have to look and you'll see it. Now, here's the key. And I'm going to show you in a minute how extremely interesting copper is as a material to use as the venturi. Now, here's the photon. Boom, that's light. Just before it explodes in the venturi, we can see it turn into electrons. Now, the electrons themselves have a black particle in the center and then white surrounding it, exactly identical to what magnets have. And magnets oppose each other just like this. The little black balls surround and they go around and they come in way down here, but coming through here is only electrons. Electrons, a cloud, surrounds copper like you would not believe. And I can show you and I can prove it, because magnets falling through the soup of copper, it's just like it was in a soup. You'll see it uno momento. Now, I am saying these little black spots that are attached to the electron and separate from the electron are muons, and as this high-speed electron is called an electron, which was Cherenkov radiation, which is high-speed electrons, and they're dark particles. We're going to see this all in a minute, and I'll show you exactly what they say, what they write about it. Now, all you need to do this experiment is a cell phone. Now, Rod used this old Samsung Galaxy, this is a Galaxy S3, Roman numeral 3. That's all he used. And he used the selfie part, and he put it right up against the output of the laser. That's what he showed me. Now, I didn't get too deep into it. Like I said, this is all he used too. It's exactly what he had. This is exactly the stuff he had. I'm showing you all these unbelievable photographs from is strictly this stuff. A Bosch GLM 15. He's got the metric version. This is the, inches version. He has the metric. Now, but it's a Bosch, and it's you push it, and the laser comes out, and it's a pulse red laser. and it comes out of here. Obviously, don't look into it. And then I believe he has these same kind of lasers here. I'm not sure, but I know he's got some other ones in like a hand grip looking thing, but these are the other ones that I use. I played around a little bit, but I have no talent for this. I got to be honest with you. Rod's the guy, but I had some other guy do the same stuff. Not as good as it Rod. Nobody's done it like Rod, but you could maybe do it. And all he did was he took at the very end of the laser, where the laser light comes out, he put like some kind of molded goop like this. It was I don't know, putty. And then he put in each side, side by side, he put these pins here and here. And the light had to crash through between the two pins. And that's where he took the camera shot of it. And he would see what was coming out and what was splashing. I mean, he had literally hundreds and hundreds of pictures of just fabulous shots, really fabulous. Well, okay, my friends, this is going to be a very, very interesting day at Mud Fossil University. Before I even start, always, always, always safety. I'm going to be talking about lasers. There's red and green and blue glasses you can get, or at least be absolutely certain that you never, ever, ever get reflected or look into lasers. Now these are little lasers. Oops. And that's a laser. Now, and all this does is shoot out pulses to take the distance in, for measuring distances. These are construction lasers. Now, and this is what Rod used. It's pulsed red laser. Now he also used green and blue, and and I have all. This is exactly what he used, exactly. And you could do this yourself for literally almost nothing. Everybody just about has a cell phone. I think they all work. Now Rod used a Samsung, very old ones, Galaxy S3, and I have it right here. It's the exact same one he used. That's the exact same laser he used to do the red. He had, like I said, green and other ones. I got some magnets here that show. You see the different things that happen in magnetism. We're going to look into all of this stuff, but I have ways to see things that they have just dismissed. I could see what's going on there. You see the different fields that are being set up, the glow and so forth. I'm starting to understand this quite well, and I'm going to be able to display this quite well. And I'm going to tell you right now that these particles that we call atoms are nothing more than more and more and more of a snowball. Just like you took these particles right here, and you took a ball of these, and you had 1,837 of them, that would become hydrogen. If you had 7,352 of them, it would be helium. There's not big, huge protons. They are 1,837 electrons at a resonance stable frequency, exactly what Tesla said. Look to vibration. Look to vibration. At a certain vibration, bang, they become semi-stable. They're not stable. Absolutely not stable. Not a single one of them. Every single one of them has isotopes, even hydrogen. Hydrogen is so far many isotopes you can't believe it. And they realized that they got all kinds of problems with the with the atomic nucleus theory. If you extrapolate it out into how they react with each other, you can more or less get a feel for what's going on with physics. But it's so far wrong now, it's absolutely unbelievable. Absolutely unbelievable. When I show you the truth of what things are about, and it's so simple, you can do it yourself. You can do this at home yourself. I'm going to show you how.